whether the value of a given quantity exists. If an answer does not exist, enter DNE, does not exist. All right, that is your graph. It's asking you f of -2. Am I looking for limit? Am I looking for y value? Y value. So x equal to -2. So where do I come? Right here. Do I have a y value? No, because it's asymptote, which means you know it does not exist, right? So I'll simply put DNE. Next one. Now, well, I told you it's looking for limits. So I don't even have to guess, right? It says limit f of x when x is approached to where? -2. All right. Okay, this is actually, it does not exist, we know that, right? Because if limit exists, what do you have to do? From left-hand side and then right-hand side, they have to what? Meet? Do they meet? In fact, the left-hand side, what does it do? You go into -infinity. What about the right-hand side picture graph? It goes to where? Positive infinity. So no, it doesn't exist. Look at this problem. This is a good problem. Is at x equal to 2, does the limit exist? Yes or no? Yes. Why? You're coming from the left. You look at this is your point. Look at the left-hand side of the picture, look at the right-hand side of the picture. Do they meet at the same place?
Yes.
Yes, then it's a limit exists. Now look at this -2. Are you with me? Look at the graph to the left, graph to the right. Do they meet?
No.
No. That means what? Limit does not exist. Does it make sense to you? Put your hand right there and then say, hey, do they meet to my hand? Are they coming to the same place? Then limit exists. If it does not come to the same place, you're gonna say what? Limit does not exist. All right. How about over here? Does limit exist at 0? No, why? From the left-hand side, it goes to where? Like 0.5?
Hey, is this the same number 11?
My 11.
Oh, I was like,
Yeah, your 11. It's your algorithmically they create a new problem for each person. Some of you guys may have the same problem, but it's supposed to be not. It's supposed to be not. So this one, is everybody see their limit is not exist? X equal to 0. Why? From the left-hand side, the limit is 0.5. From the right-hand side, the limit is what? 4. They're not same number. Does it make sense to you? You can physically tell, you have to physically tell from the left-hand side of the graph, right-hand side of the graph, if they meet at the same place, you have a limit. If they don't meet at the same place, that means what? The limit does not exist. Does it make sense to you? Yes.
So you saying like when you approach from the left and the right, you get a different value. It do not exist.
You don't have the limit, right? You don't have the limit. In lesson 2, and actually lesson 3 and 4, we're gonna talk about one side limit. They will say, hey, I want to know the limit from the only one side. So does it exist? Like this picture. I don't care about the right-hand side. Hey, can you just look at the left-hand side of the picture? Does the limit exist? You're gonna say yes. Well, which is 0.5. I'm gonna say, hey, does this limit exist just from the right-hand side? Yes, 4. But then there's a problem says, does this function has the limit at x equal to 0? Then you're gonna say no. It only has one side limits. I'm kind of going ahead for my next lesson talking to you right now. So there's a the limit, which means what? I'm looking for the left-hand side, I'm looking at the right-hand side, they meet in exactly where? The same point. And then I'm gonna say, hey, let's not worry about the limit, but let's just talking about the one side limit. From the left-hand side limit, and then what? Right-hand side limit, does it exist? We can talk about that too. Are you with me? Okay. All right, so far so good. Okay. This is very, very good. F of 0. Okay, f of 0. Am I looking for value? Am I looking for limit? I'm looking for value, y value, right? So f of 0, that is not the value. That is such what? I don't know. It's a circle. It's not exist. So where is f of 0? 4. 4 has a what is called a solid circle, which means it has a value. So which is y is equal to 4 when x equal to 0. Is everybody with me? see the difference? This is another good problem right here. X equal to 4. What's my y value?
That's one.
1.
That's on there too. It's G.
Is everybody with me?
Yes, ma'am.
The limit is approaching to infinity, but the y value is what? 1. This is a very good problem. I like problems like this because you get to think about it, the difference between limit and a y value. I have a y value. Is everybody with me? F of 4 gives me 1. Is everybody with me? But limit x approach to 4 of f of x is what? Is it 1? No. Where is this graph approaching to? Infinity to the right. Infinity to the where? Left. The left hand side is approaching to infinity. Right hand side is approaching to where? Infinity. So my limit is actually infinity, going to the positive infinity. So they don't have a same number. So that's why it's discontinuous. Continuous means they be the same place.
What would we put in discontinuous? Infinity? Or?
They want to put infinity where does not exist.
Does not exist.
Okay, so yes, that's fine. You can, for right now, they can't say, since we do not introduce this yet, that's introducing a lesson 3 and 4. So they want to just use it right now for what? Does not exist. That's fine. But the later lesson, they will tell you to use infinity, then you can use infinity.